Hi everyone. In this video, we are going to discuss few key metrics related to data transfer. We'll explain these metrics with the help of simple analogy. By end of this video, you will have a good grasp on the key concepts which you can apply in designing and planning such complex data systems effectively. So without further ado, let's get started. So we will discuss 5 key metrics. The first one is bandwidth. The second one, which is related to bandwidth, is throughput. Third one is quite important, latency. Fourth one is ingress. Fifth one is just opposite of ingress, which is egress. We will discuss these 5 metrics using water pipe analogy. We will also briefly discuss about their nuances. So let's discuss bandwidth first. Bandwidth is the amount of data that is transmitted through a channel or medium or connection in a unit of time. Here in this case, the connection or medium is this pipe, and the amount of data is the amount of water. So if I open this face of this pipe for 1 minute and start collecting the water into a bucket, and let's assume in 1 minute I have like 60 liters of water collected. So the bandwidth, as per the definition, would be the amount of water in a unit of time, so 60 seconds. So it will be 1 liter per second. So bandwidth basically defines the maximum capacity of a channel, and then it gives you a reference point. It tells you how good your transmission rate is with respect to the bandwidth. If you are far behind, it means your system is underutilized. Your bandwidth is underutilized. If you are pretty close, it means you need to increase the bandwidths. Otherwise, you may lose the information, or you may have a bad quality of service of the data. Bandwidth also influences the throughput of the system, and if the bandwidth increases, the throughput also increases. So higher the bandwidth, in theory, the higher the throughput. But in case of latency, if you increase the bandwidth, chances are good that your latency will be decreased, which is good for the system, because the data would start reaching to the destination earlier. If I increase the diameter of this pipe, it means I'm increasing the bandwidth of this pipe, because in a unit of time, the amount of water which is now getting collected may then become 90 liters. It means I'm increasing the bandwidth. So bandwidth plays an important role to understand the overall health of the system, the overall capacity of the system, and it acts as a reference parameter for other matrices. So now let's discuss throughput. So let's take the pipe example again. So we have a pipe and we are inputting some water, and we are also getting some water from here. But the water may not cover the entire pipe. It may not be 100% utilized. So here, let's say only some part of the pipe is getting utilized. Only this part of the pipe is able to transmit the water. So the way we calculate throughput is the same as bandwidth. So let's say again I open this phase for 1 minute, and I started collecting the water into the bucket, and this time instead of 60 liter, the amount of water which is collected is 30 liter. So now what is the throughput here? The throughput here is 30 liter divided by 60 second, and it is 0.5 liter per second. Clearly you can see that this is very less than the bandwidth, which is 1 liter per second. It means either you need to do something at the source so that we can pump more water, otherwise the resources here are being underutilized. So throughput is a very important metrics because it tells you the actual state of the system, unlike the theoretical value of the channel. It tells you the actual how actually the data is getting transmitted, and the unit of throughput is same as bandwidth. Okay, so this is all about throughput. Let's discuss another important metrics, which is latency. Latency is the time it took for data to transfer from source to destination. It is a measure of delay. In our analogy of water and pipe, let's assume we are transmitting the water in gallons, and each gallon is of 1 liter. So we have multiple gallons, each of 1 liter. And this water is getting now collected from the right hand side, which is our destination, in bucket. And let's say the first time this gallon was entered here was T1, and the time it was received in the bucket was T2. So the total time it took to reach at the destination is nothing but the latency, and here in this case is T2 minus T1. Usually this latency is measured in microseconds, but sometimes, which are time critical, it is also measured in microseconds. Latency is a very important parameter in applications which are time sensitive. For example, real-time pricing. Real-time pricing in trading applications. It could also be important in some applications, for example, online recommendation of products for customer in e-commerce. The lower the latency, the better the system is, the more efficient the system is. So that's about latency. Let's discuss two other metrics. One is ingress and the other one is egress. The ingress is the amount of data which is getting transmitted into a system. Conversely, egress is the amount of data which is getting out of the system. With the water and pipe analogy, let's say the amount of water which is getting entered from the left hand side is 100 liter, and the amount of water which is being collected from the right hand side is 90 liters. The ingress here would be 100 liters, and the egress would be 90 liter. So the unit of ingress and egress is either the quantity or the amount. And it is quite important to understand these two metrics, especially in the data application, to have a better data integrity and better quality of service. I hope you have liked this video, and this knowledge would help you to understand the complex data systems or networking system easily, and it may also help you to design and plan those systems in more effective way. Thank you for watching.